In this presentation, we'll be finding the area of complex shapes. And there are two different ways we do that. Sometimes we take simple shapes and we have to add them together to find the area. Sometimes we have to take the area of simple shapes and subtract them to get the area. And we'll go through both examples in just a minute. So before we get to complex shapes, let's acknowledge how much you all already know about finding area. We've already learned how to find the area of several different types of shapes. You know how to find the area of various types of quadrilaterals, including parallelograms, and different types of parallelograms are rectangles, rhombi, and squares. You know how to find the area of trapezoids, and you know how to find the area of kites. So you also know how to find the area of triangles. However, sometimes we need to find the area of shapes other than these simple shapes. And to find the area of these complex shapes, the first step is to break them down into simple shapes. So let's do an example and see how that works. So if I were asked to find the area of this shape here, the first thing I would notice is that it is actually made up of two simple shapes that I know how to find the area of. It's made up of this parallelogram, which I'll put in red, and this triangle, which I'll put in blue. So my strategy is going to be, first, I'm going to figure out the area of this parallelogram. Then I'm going to figure out the area of this triangle, and then I'll add them together to get the area of the whole thing. So the area of a parallelogram, as I know, is base times height. Using substitution, I can plug in values for base and height of 8 and 11, multiply that out, and I get 88. So now I know that the area of that parallelogram is 88, but I still have to find the area of that blue triangle right there. So finding the value of the area of a triangle is 1/2 of base times height. The problem is, for this particular triangle, I don't have a base. But what I do know is that a parallelogram, that parallelogram in red, the opposite sides are equal because the opposite sides of a parallelogram are congruent, so their values are equal. So if the base on the left is 8, the base on the right is 8. So now I can use that to plug in my values for this triangle. I can use substitution to plug in my value of 8 for the base and 9 for the height. Multiply that out, I get 1/2 of 72. Multiply that out, I get 36. Now I simply have to add the values together because I want the whole thing. So 88 plus 36, when I add them together, I get 124. So the area of this entire shape together is 124. Sometimes, when we're using complex shapes, we're not given all the necessary information, and we have to calculate what a value of a missing side is before we can solve the problem. Let's look at an example of that. Imagine I were asked to find the area of this complex shape. Well, the first thing I would do is I would recognize that this complex shape is actually two different rectangles, the big one over on the left and the small one over on the right. But the problem is the value, or excuse me, the formula for the area of a triangle is base times height. But I don't have a height for the triangle over on the right, nor do I have a base for the triangle on the left. So I need to calculate the values of x and y before I can calculate their areas and add them together. Let's see how to do that. I notice that over on the left I have a value of 18, so I'll put that in blue. And because the opposite ends of a parallelogram are equal, or they're congruent, so their measures are equal, and a rectangle is a type of parallelogram, then I know that if the value on the left is 18, I'll put it in blue. The value on the right, which I'll put in blue, is also 18. And I know that this value here in purple is 6. So if I subtract those, I get 12, which is what's left over of that side. Well, I'll put in green right there. That's 12. And since that is 12 and it's opposite sides of a rectangle to x, then x is also 12. So now I have my height of the rectangle on the right, but I still am missing a base of the rectangle on the left. Let's go through and see how to do that. At the bottom, I notice I have a 31 in yellow. I'll put it in yellow right there. And so this value right here is also 31. If I subtract out this piece in pink here, and I subtract it out, I get 24. So what's left over here is 24. And so if that piece in red is 24, then that piece is 24, and that piece is 24. And so now I have all the values I need to be able to calculate the areas. First, I'll calculate this rectangle in blue. The formula for the area of a rectangle is base times height, so it would be 24 times 18, which equals 432. Now I need to add it to the rectangle in red, which is the base is 7 and the height is 12. Multiply that out, I get 84. Add those together, and I get the entire shape, which is 516. So sometimes we need to calculate the shapes before we can multiply out to get the area. So far what we've done is all the shapes are additive. They're two different simple shapes, or can be multiple simple shapes that we add together. But sometimes we want to find the area of a shape, we want to subtract. And so if I were asked to find the area of the shaded portion below, then I would notice that it is a rectangle that's big and a triangle that's on it that's small. And if I subtract the big rectangle and then subtract out the small triangle, I'm left with what's the shaded portion. So let's see how to do that. The formula for the area of a parallelogram or a rectangle is base times height. Using substitution, I put in my values of 13 and 4, multiply those out, and I get a value of 52. To find out the area of the triangle, my formula is 1/2 base times height, but I don't have a height. But I notice that the rectangle and the triangle have the same height of 4. So now I can plug in that value using substitution. So 1/2 of my base of 5 and my height of 4, multiply that out, I get 1/2 of 20 equals 10. So now I simply have to subtract them. 52 minus 10 equals 42. So the area of this shaded portion of this shape above is 42.